Hello friends, welcome back to my YouTube channel Data Operations and Research. In this video, I'm going to show you how to merge NSSO data and apply weights to it. For merging the data, we are going to use NSSO 71st round extracted data that we calculated in the previous video. If you haven't seen that video, then kindly go and check that video. Link to that video is in the description section. This video will show you step-by-step procedure to merge all 6 levels of extracted data. I will request you to merge along with this video so that you follow the steps clearly. Therefore, if you don't have the extracted data or facing difficulty in extracting the data, then watch our how to extract NSSO data in STATA. Link to that video is in the description. This video will only deal with merging the extracted data and applying weights to it. In the upcoming videos, I will show you how to create new variables for analysis like rural, urban, male, female, different states, etc. Also, in an upcoming video, I will explain all the files and how NSSO samples are created. Lastly, in the previous video, there were some valuable suggestions in the comment section, so I will be making videos covering those suggestions as well. Before we begin, I will urge you to watch this video on a laptop because at certain times, commands may become small to be readable on phone. So let's start with today's video. For merging and applying weights to the NSSO data, following files are required: extracted data, readme file, IHSN study report NSS 71 in the supporting documents folder for cross-checking the merged file. So here is our NSSO 71st round data. We will open it. So you can see we have stored the extracted data in this folder. So here we have our 6 extracted data. Then we will go back. Then here is our readme file. I have already opened it, so here it is, you can see. And third, we need the IHSN report, study report. So in supporting documents, here we can find the IHSN study report. So we can open it. Here is our report. Now steps involved in applying weights. From readme file we get the weights. So if we go to the readme file, as we scroll down, we can see that here it is given: apply final weight for subsample combined estimates as follows. Final weight is equal to MLT divided by 100 if NSS is equal to NSC, and final weight is equal to MLT divided by 200 otherwise, that is when NSS is not equal to NSC. So we have written the same weights here, and the command in STATA is generate weight equal to MLT divided by 100 if NSS double equal to NSC. Now in STATA, to represent equal to sign, we have to use double equal to sign. So if we have to show that A is equal to B in STATA, we have to write A double equal B. Similarly, for the case when NSS is not equal to NSC, that is otherwise, we will replace weight equal to MLT divided by 200 if NSS exclamation equal to NSC. In STATA, to represent not equal to, we use exclamation equal to. Once we apply this command, we will observe an error. This error arises because our data is in string form and we are dividing it by a numeric 100 to 100. Therefore, we will first convert string variable into numeric variable. So the command for converting string to numeric is dstring variables, those we need to change, and then we will replace them. So what I am doing here is I am going to first explain the process of applying weights and merging the data, and then I will do the entire process in STATA. So this is the steps for applying weights. Now we will move on to merging the data. So the most important point to remember while merging the data is to be careful about the data level that we are currently working with. For level 1, 2 and 3, we will be merging the data using household ID. For merging level 3 with other levels, we will using person IDs. That is, for level 3 and onwards, we will be using person ID. To generate household ID, we need FSU serial number, Hamlet group or segment group, second stage stratum number, household number. So if we go to our readme file, we can see that common primary key for identification of a record for any schedule is FSC serial number, segment number, second stage stratum number, household number, level number, and item code. So we only need the four of these, FSU, segment, second stage, and household number, to create household ID. Now a question might arise that why are we not using level number and item code along with these 4 variables? So this question will be answered in the upcoming video, where I will explain all the variables, what they imply, how they are generated, and various other topics covering the files and variables. Because if I go into explaining these variables right now, then the video will go off topic and unnecessarily become lengthy, and the primary objective of this video is to merge the data. So again, and to generate PID, we need household ID, that we had here, and person serial number. Now another question that arises is that why do we need to generate household ID and person ID? PID stands for person ID. Well, in STATA or any other statistical software, we need a common variable to merge 2 different data sets. And as we have 6 levels of raw extracted data, therefore we need to generate household ID and person ID to act as the common variable to merge the data. So moving on. So the discussion in the previous slide implies that we need to calculate household ID for all the levels, and PID is calculating using household ID. We will calculate PID for level 3 and above. Now the question arises, why PID? We need to calculate PID because level 1 and level 2 deals with household information, whereas level 3 onwards deals with individual information. So I will show you this in the data layout. So as we will open the documents, so in supporting documents we have the data layout. So if we see that this is our level 1, this deals with, this basically tells us about what is the region that we are going to cover. Then this gives us the household characteristics. But if we move to level 3, then here you can see that person serial number, relation to the head, sex, age. So these things cannot be characteristics of a household. These are characteristics of an individual. Therefore, third level onwards we start dealing with individual. Therefore we need to calculate person ID for third level onwards. So another question that arises is that why don't we create PID for all the levels of data and use it to merge the different levels, instead of creating first household ID then person ID? Well, the answer is we cannot calculate PID for level 1 and 2 because it does not contain person serial number. As we saw in the previous slide, that PID is calculated using household ID and person serial number. So it does not contain person serial number. Also, level 1 and 2 deals with household information, so we cannot get any information about the individual in that from those levels. So moving on. Now how to generate household ID? Now commands to generate household ID are generate string. Now as we have seen that we have to use FSU, Hamlet, second stage stratum number, and household number. So we have to first generate these variables. So generate string, we will use small letters FSU equal to substring of common ID of the particular level that we are trying to generate the household ID. Then 4, which is the byte, and 5 is the length for FSU number. Now the question is, where did we get these numbers 4 and 5? So if we go to readme file, here we are given that FSU serial number is of 4 byte, that is it lies fourth in the common ID, and we have to use 5 out of them, and we have to use the FSUs of the 5 numbers from 4th digit onwards. So we will generate FSU using this particular command. Similarly, we will use generate string ham for ham equal to substring common ID. Now for Hamlet group it is 32 1. So we will be common ID, and from common ID from 32nd position we will take one digit to create to generate Hamlet number. Now these things might sound confusing, but I will show you in the when we start generating these variables in STATA, that okay, this is the common ID, what portion have we taken out of it, and this is what happens with it. Similarly, to generate second straight stratum, we will use generate string SSS equal to substring common ID. Now for second straight stratum it is 33 comma 1. So we will be using 33 comma 1. Then for household ID we will be string household ID substring common ID 34 comma 2. Sorry, here there should be a generate string household. Sorry, it happened by mistake. Then lastly, to generate household ID using the 4 variables that we have generated, we will be using generate household ID equal to FSU plus HAM plus SSS plus household plus HH. Now one thing to keep in mind is that the order of this addition must remain the same. That is, we cannot use HAM before FSU or any other combination, because what happens in adding in generating household ID by using this command is that the data containing to FSU is put before HAM, and similarly. Now to generate PID, we will use command generate PID equal to HHID, which we have generated here, plus person serial number. I will show you where we can find the person serial number. It is in the data. It is given in the data. And also this why we need to keep the order same, I will again show you when we will be working with the data. Now moving on. Now commands to merge the data. So in the previous slide we generated the variables. Now we will be merging the data. So the command for merging the data is merge 1:1 /m for household /PID using the file path of the data to be merged. So when will m come? So it will be either 1:1 or 1:m, depending on the level of data we are working with. Similarly, it will be either household ID or person ID, depending on the level of data we are working with. So 1:m condition will arise when we will be merging level 3 data. For all other levels, merge 1:1 will be used. PID will be used for merging level 4 data onwards, as PID is the common variable between the data sets. So here is the sequence of step. So first we will destring NSS, NCS and MLT for all levels. Then we will apply weights. Then we will generate household ID for all levels of data. Then we will generate PID using household ID for all 3 levels and for level 3 and onwards. And then we will open level 1 and merge the subsequent levels into it. So let's start with the actual application of weights and merging of data. So I will open STATA. Here I have opened my STATA, and I will first bring my level 1 data. So to bring my level 1 data, I will press open, and this is my data folder. I will go into extracted data, and press level 1 and I will open it. So we have brought the data here. Now the first thing that we have to do, as we have seen, is first we have to destring NSS, NCS and MLT for all the levels. Now as we have shown here, that this is the weights that we have to attach, this is the command for generating the weights, and this is the command for destringing the variable. Now first try generating the weights without destringing it and see what error comes. So the command for generating weights is, I will slightly minimize it. So the command for generating weights is generate weight equal to, now if we scroll down here we will find that MLT is given here. So MLT A37 divided by 100 if NSS, so NSS double equal to NSC, so NSC, and we will press enter. So what we find is that there is a type error, type mismatch. So we will open it. What is the error? So in an expression you attempted to combine a string and a numeric. So this is the problem that we discussed. So therefore we need to first destring the variable. So to destring, dstring, destring, we will take these three variables, comma, replace, and once we destring them, so all the numerical all the characters that were numeric have been replaced as byte. So now we can apply the command. So now we will apply the command again. So generate weight equal to MLT divided by 100 if NSS is equal to NSC, and we can see that the weights have been generated and 65,898 missing values have been generated. Now for the case otherwise, the other case, that when NSS is not equal to NSC, we will use generate weight equal to MLT divided by 200, as that was the that is the number that we have to divide it. So divided by 200 if NSS is not equal to, so for not equal to it is exclamation equal to NS, and we will press enter. Sorry, my bad. See what happened is we wrote generate weight equal to A37 divided by 200, whereas what is the command that we have written? Replace weight. So these are the things that we have to be careful while doing this. So I can simply click here to get the same command here, and I will simply delete it and replace and press enter, and you can see that weights have been generated and 65,898 real changes have been done. So we have successfully applied the weights for first level data. Now the second thing that we have to do is to generate household ID and person ID, household ID, because person ID will start from third level. So for household ID we need FSU serial number, Hamlet group, second state stratum number and household number. So these were the commands for generating household ID, but the thing to keep in mind is that for first level data, these things are already provided. So if we see FSU serial number, A2 is our FSU serial number. So for first level it is already given. Then for Hamlet group or segment, this is our A14 is our Hamlet group. Then second stage stratum is A15, and then household number is given by A16, sample household number. So that means for first level of data, we do not need to generate these variables as they are already given. So we will simply generate household ID using this particular formula. So generates household ID equal to, we will add these. So I will show you. Generate household ID equal to, now FSU is our A2 plus Hamlet number is our A14 plus second state stratum is A15 plus household number, so A16, and we will press enter, and you will see that our household ID has been generated here. So we can browse it, browse household ID, and we can see, we press enter, that's here our household ID has been generated. So now we will close it, as all the necessary variables are generated. So we will save this. So to save it, we will use save comma replace, that is in the existing extracted data, save these changes that we have made. So save and replace, and these changes have been saved. So now our first level data has been completely prepared, that is weights have been applied and the necessary variables have been generated. So now we will remove the first level data and bring the second level data. So to remove the first level data, we will use clear, and you can see that our first level data has been removed. Now we will go to again open, choose second level data and press open, and you can see that our variables have come here. Now so now the first thing that we have to do is apply weights to it. Now as we have already used the formula to apply weight, and so we can directly use those particular formula, but we have to be careful. For example, first we have to destring it. So here is the destring command, but the thing is that here it is dstring A35, however we have B17, B18 and B19, so we cannot use the same command that we have written here. So we will change it first. So dstring, we will delete it, and then choose NSS, NSC and MLT, and we will replace them. So, and numeric has been replaced by byte. Now we will have to apply weights. Now to apply weights, we will use gen weight equal to MLT divided by 100 if NSS is equal to NSC. Variables have been generated, and now for the otherwise case, we will have to first replace weight equal to MLT divided by 200 if NSS is not equal to, so exclamation equal to, and we will press enter. Sorry, we have again made a spelling mistake, so we will just write it and replace, and see 65,898 real changes have been made. So what you can see is that our weights have been applied. Now in the first level data, we had all the FSU number, Hamlet number, second stage stratum, household ID, etc. Sample household number. But here we don't have any of those. So what we have to do is we have to generate them, and to generate them we use common ID. So now we will have to generate those variables. Now to generate those variables we will use the command. So we will first generate FSU number. So generate string FSU equal to substring bracket. Now common ID is b1 comma, now it is of 4 byte and 5 length, so 4 comma 5, and we will press enter. So what we can see is that our FSU has been generated. And now you might ask that what was the use of using common ID 4 comma 5. So we will browse these two variables, b1 and FSU, and what you can see is that here is the common ID. So this is the common ID, b1 is the common ID, and this is the variable that we have generated. And what we have written, that b1 4 comma 5. So the fourth byte is 3, and we have to use the next 5 length bytes to create FSU number. So the fourth is 3 and the next 5 are 3773. So using this particular command, what we have done is we have taken a long string variable and we have created a small string variable, and 4 comma 5 is to define that what is the particular byte that we have to start with, and at what point, and what should be the length, so it is of 5 length and it starts from 4th byte. And so this is the reason for using b1 comma 4 comma 5. Similarly, now we will generate Hamlet. So generate string ham equal to substring bracket. Now common ID is comma and 32 comma 1, and we will press enter. So our Hamlet has been generated through common ID. Now again, if we browse these two variables, we will see that what has happened is that this entire common ID is of 35 length. As you can see here, that here is our level 2 and common ID is of length 35. So what we have done is we have taken the 32nd. So this is the 32nd. So we have used the 32nd byte value and used the used one length, that is only used one of it, defined the length as 1, and we have made a substring of that. So this is the Hamlet. Now we have to calculate the substratum. So again we will use the formula generate string SSS equal to substring bracket common ID comma 33 comma 1, and enter. And our substratum our second stage stratum has been created. Now we have to create sample household ID. So again the formula is gen string household equal to substring bracket common ID comma 34 comma 2, and we can see that our household has been created. Now if we browse it, so common ID household, and we can see that since our common ID is of 35 length, so we are using 34th the 34th byte, and it should be of 2 length. So the 34th byte is 0 and it is of 2 length, so we are just creating a substring of 0 1. So our substring of household has been created using using common ID. So we have created the 4 variables to create household ID. Now to create household ID, the command is generate household ID equal to, now we have to keep in mind the order. So FSU plus Hamlet plus SSS plus HH, and we will press enter, and you can see that our household ID has been generated using this. Now if we browse these variables, you will see that browse this FSU, HAM, SSS, HH and household ID. What has happened is that it has taken all these variables and it has created a new string in this particular order. So 3773 is first, then 1, here is the 1, then 2, here is the 2, and 0 1, here is the 0 1. So this is the reason why that we need to be careful about the order that in which we are adding it, because if for example HAM was before FSU, then the letters then the string will be of a different nature and we will not be able to merge the data. So now we have successfully applied weights and generated the necessary variables to merge the second level of data. So now we can save this data, and to replace the existing data we will write replace. So we will save and replace the changes that we have made. We will press enter. These changes have been made in the level 2 data. Now we will clear the data, and now we have to work on level 3. So now I will open level 3, open, and you can see level 3 has come here. So first thing that we have to do is attach weights, and to attach weights I have to first destring the variables. So destring C18, C19 and C20 comma replace. So all the numeric characters have been replaced as byte. Now to apply weight, we will use the formula generate weight equal to MLT divided by 100 if NSS is equal to NSC. We will press, and these variables have been generated. Now for the other case of otherwise, we will use replace weight equal to MLT divided by 200 if is not equal to, so for not equal to the sign is exclamation equal to NSC, and we will press enter, and all the changes have been made and we have applied weights to the data. Now we have to generate the variables. So again we will use the commands that we have already written here. So now one thing we can check to simplify the process is that as we have already applied the commands previously, so can we use those commands again? So this is the command for creating FSU. So generate string FSU equal to substring. Now the thing is we are not in second level and this is the common ID, and here our common ID is represented by C1. So we can replace this by C, and if we press enter, then our FSU has been created. So this is an easier method of, instead of writing the entire command from scratch, we can simply replace the common ID name and we can press enter. So the only thing is that this is a very easy method, but we have to be careful that we don't apply. And suppose what happens if we apply the wrong formula, so it will say that B1 not found, that is our common ID here is there is no name as variable as B1, therefore it will show that B1 is not here. So we will again write this command and we will change B to C, we will press enter, and then our Hamlet group is generated. Then SSS, we will replace B by C, press enter, our SSS has been generated. And then for household we will again use the same thing, that we will replace B by C, and we will press enter, and it has done. Now to generate household ID we will write it, and since the name of the variables are same and the variable names are same, therefore we can simply use the command that we have previously used, and we will press enter, and you can see that our household ID has been generated. Now as we have discussed here that we have to generate PID for level 3 and above. So here we have to generate, sorry, just a second, I will just open it here. So here we have to generate PID. So the command for generating PID is generate PID equal to household ID plus person serial number. So generate PID equal to household ID plus, and you can see here that we have C4 as person serial number, so we will add C4 and press enter, and you can see that our PID also has been created. Now while merging I will show you that why we had to create PID and household ID. When we will be merging it, I will show you why it is happening. So as we have applied weights and generated the necessary variables, so now we can data, save and replace it, so save and replace. So our data has been saved and the necessary changes have been made, and now we will clear it, and data has been removed. And now we have to make changes in the 4th level data. So we will open the 4th level data, we will open it. Now again we have to generate those variables. So as we have used the command here, so sorry, first we have to generate weights. So for generating weights, the command is, now the thing is that can we use the commands used previously to generate weights? Well, let's check it out. So here is the command for generating weights. So generate weight equal to C20 by 100 if C18 is equal to C19. However, we can see that there are only 16 variables and this is way too many, and we will have to make too many changes. Therefore, we can either make changes here or we can simply write the command and execute them. So first we will destring it. So dstring NSS NSC MLT comma replace. Now first I will apply the commands, and the second time I will use the already used command to show that we get the same result. So first generate weight equal to MLT divided by 100 if NSS is equal to NSC, and we will press enter. So 93,473 variables have been generated. Now for the other case we have to replace. Now replace weight C20 divided by 200. Now here we have to see that what is the MLT. So MLT is D16, so we have to D16, or we can either do this, that we can simply press here and D16 will come here, divided by C now NSC, so it is D14 and this is D15. So and we will press enter and the changes have been made and our weight has been generated. So you can see that the chances of making error so first we will use the command, and as you can see that everything remains the same. We have to only change the common ID name. So here the common ID is D1, so I will just change the D1, press enter, my FSU has been generated. Then for Hamlet I will use D1, press enter, Hamlet has been generated. For substring stratum D, second stage stratum has been generated. And then for household I will use again D, press enter, my household variable is generated. Then I have to get the household ID, so nothing needs to be changed here, press enter, my household ID has been generated. And now I need to create person ID, so generate PID plus C4. Now here we have to be careful that here person ID is represented by D4, so I will change the C by D and press enter, and I can see that my PID has been, my person ID has been also generated. So now I can save comma replace the data, so it has been saved, and now I can clear it. So one thing that you can observe is that it is not a difficult process, it is just that the process is repetitive and we have to be careful with what particular variable we are using. Are the names correctly specified? Are we the spellings that the spellings are correct or not, etc, etc. So we have applied weights and generated the variables for level 4 data. So now we will get back to level 5 data. So we will open level 5, we will open it. So we have opened the level 5, and as you can see that previously there was only 16-17 variables, now we have 38. So now we have to first we have to destring the variables to apply the weight. So dstring dstring NSS NSC MLT comma replace, enter. Sorry, as you can see only E36 and E38 has been replaced. We did not replace NSC, so we have to destring this also. So d string e37 comma. So these are the small details that we have to keep in mind while merging the while working with STATA, that sometimes if there is not a proper click, then that data doesn't get selected. So we have to be careful while doing this. And for example, if say we forgot to destring e37 है ना, and we ran the command for applying weights, then the error would have showed, and then we had to again make those changes. So it is not like that if we make a mistake then it is end of the world. No, if we make a mistake, STATA will tell us that we have made a mistake. We can go back and rectify the mistake and things will come out perfectly. Now we have to generate weights. So generate weight equal to MLT divided by 100 if NSS is equal to NSC. Enter. These many variables have been generated, and replace weight equal to 38 divided by 200 if this is not equal to, so exclamation equal to E37, and so our weights have been generated. Now we have to create the FSU, Hamlet, second stage atom, and household variables. So we will simply generate string FSU from substring. Now here it is D1 and we are in E1, so we just need to be little careful. E1, and we have generated FSU. Similarly again from D1 to E1, enter. HAM has been generated, then again E, and SSS has been generated, and then again here we will use E, and our household is generated. Now we have to get household ID. So get household ID using adding these four, so it is there itself. Our household ID has been generated. Now we have to generate PID. So PID is household ID plus E4. These are the things need to be careful. E4, so person serial number, we will add it, and it has been done. Now we need to save and replace. So save and replace. Our data has been saved and the necessary changes have been replaced in the data. Now we'll clear the data. Clear. So we have applied weights and made and generated necessary variables till 5th level. Now we have to make those changes in the 6th and the last level. So we will open the 6th level. Open. Now we have to first destring it. So dstring. We have to choose the variables F16, F17, F18. These corresponds to NSS, NSC, and MLT, comma, replace. The changes have been made and numeric has been replaced with byte. Now we have to apply weight. So gen weight equal to MLT divided by 100 if NSS is equal to NSC. 51,000 plus missing values has been generated, and now replace weight equal to MLT divided by 200 if NSS is not equal to NSC, and weights have been successfully applied. Now we have to generate the variables. So first we will generate FSU. So generate string FSU equal to substring. Now we are in 6th, so it is F. So common ID is given by F1. So we have to change it to F1. Enter. FSU has been created. Then for Hamlet group, again F1, Hamlet group has been created. For second stage stratum, again F1, it has been created. And then for household, F1, and our household variable is generated. Now we have to generate household ID. So generate household ID equal to FSU plus HAM plus SSS plus HH. We will press enter, and our household ID is created. Now we have to generate person ID. So generate PID equal to household ID plus common ID. Now common ID is not common ID, person serial number. So person serial number is given by F4. So we will use F4 and we will press, and our person ID is also created. So we have saved, we have generated the necessary variables and attached weights. So now we will save and replace it. So save and replace, enter, and now we can clear it. So enter, and we have made all the necessary changes in all the levels of data, and now we can start with merging the data. So now the command for merging the data is merge 1:1 M household ID or PID according to the situation, and give the file path of the data to be merged. So we will act accordingly, and here we have said that the most convenient way, at least for me, is to open level 1 and merge the subsequent levels into it. So what I'm going to do is start with level 1 data and start merging the subsequent levels into it. So here is my STATA. I will open the first level data, open it. So here everything is there. Now to merge the data, we have to just be careful. Here is our PowerPoint. Here is the command. So we will keep them together. So for merging, it is merge 1:1 household ID using. Now we have to give the file path of the data to be merged. So we have opened the first level data and we want to merge the second level data into it. So we have to give the file path of the second level data. So to get to the second level file path, we will go to extracted data. So here it is our second level data. Now we will press and hold the shift key, right click on it, and we will get copy as path. So we have copied the path, and we will go to STATA and we are going to paste it. So merge 1:1 household ID using, so merge household ID using this. So in both of them we had the household ID in level 2. So we will press, and we made a mistake that merge 1 is no command, so we had to add a space. So merge 1:1, and we will press enter, and you can see that here is our first level data and we have brought the second level data into it. So the results show that we have matched 65,926 and zero variables are matched. So that means all our variables have been matched successfully. Now to cross check it, we will go to the IHSN study report and we will go to block 1 here. It is generally so it is given here, and it shows that for first level we should get 65,926. Why we need to cross check with it is because at times what happens is that there can be certain variables which were not matched. So those things will show here that this is the number of variables that did not match, and it can be the case that the nature of data is such that there are certain variables that there are certain observations that don't match. So if there are such observations, then it will show here that for level 1 these many should match and these many will not match. Therefore this is the therefore the role of this study report is to check whether how many should match, how many should not match, and if everything is matching, then it is very good for us. So you can see that we have successfully merged the second level data in level 1. Now we have to merge the third level data. So before doing that is we have to drop this particular variable, because if we try to merge without dropping it, then an error will show. So so to drop the variable, we will use drop this, and the variable has been dropped. Now to merge the third level data into now the first and second level combined data is merge 1:1 household ID using, and now we have to bring the file path of the third level data, as now we are trying to merge that here. So we will open the extracted data, right click on it, we will press and hold shift key, then right click on it, go to copy as path, then we are going to copy that path here, and we are going to so what happened here is that it says that variable household ID does not uniquely identify observations in the using data. And do you know why it happened? It happened because from the third level onwards, the data changes from household to individual observations. So that is why we had to create person ID, and here we have written that 1:m condition will arise when we will be merging level 3 data. So this is the reason why that we were shown with the error. So we will again use the same command and change it with m, and we will press enter, and you can see that our third level data is now in this particular data. So now we have first level, second level, and third level data in one file. This is the now what you might ask, that why did we use why do we need to use 1:m? Well, the answer is that in an household there can be number of individuals. So there will be one household, but there can be more than one individual in that household. So there is a 1:many relationship. So to show that 1:many relationship, we have to use the use merge 1:m. And since this is household and this is these are individual person these have individual records. So but since the second level data does not have a person or individual records, so we cannot use PID for merging these two. So we have to use household for the third level, but so that's why we created household ID for third level, and we have used 1:m using household for the third level to extract to merge the data. Now we can cross check here that for level 3 we should get 3,10,827, and you can see 3,10,827. there are 0 mismatches or things that did not match, and here also there shouldn't be any variables that go unmatched. So here we have successfully merged the third level into our data. Now before that we have to remove this merge here. Now what happens if we don't remove it? Well, let's try without without dropping this variable. So now we have to merge the fourth uh, fourth level data here. So merge. Now as our third level data we have person ID, so we will be using and in our and I'll show you, and in our fourth level data we have person ID. So that means that we can merge the third and the fourth level using person ID, and since person ID is constant for an individual, therefore we do not need to use 1:m or m:1, rather we can use 1:1. So we will use merge 1:1 using PID using. Now we have to give the file path of the fourth level data. So we will go to our extracted folder, we will press and hold shift key, right click on it, copy as path, go to our STATA, paste it, and we will press enter. Now it says that variable merge already defined, and this error came because a merge was already there, therefore we need to drop this merge. So we will drop and we will enter, and this variable has been dropped. And now we can use this same command and we will press enter, and you can see that we have now brought the fourth level into the entire. So currently we have the first level, the second level, the third level, and fourth level in one file. So we you can see that matched there are 93,513, and if we go here, so this is level 3. For level 4 we should get 93,513. so that means we have correctly merged the fourth level data. So again we have to first drop this variable, so we will drop it. Now we have to again merge fourth level with the fifth level, so merge. Now we will be using 1:1 because now we are dealing with PID, person ID, and person ID is unique for each individual. So 1:1 PID using, and now we have to give the file path of the fifth level data. So here is the fifth level, press and hold shift key, right click on it, copy as path, we will go to STATA, we are going to paste it here, and we are going to press enter, and you can see that now we have our fifth level data in a common file. So and we have 93,513 matched observations. So we will go to block 5, and for block 5 you can see that we have 93,513, and there shouldn't be any observations that go unmatched. So that means our merging process is correct. Now again we have to first drop this merge. So as we have already used this command here, so we will drop merge, the variable has been dropped, and now we have to bring the final extracted data here. So again, as we are dealing with person ID which is unique, so we will use merge 1:1 PID using, and now we have to specify the path of the sixth level data. So sixth level data, right click on it, sixth level data, press and hold shift key, right click on it, copy as path, and then we are going to paste it here, paste and press enter, and you can see that we have now brought the sixth level data in this file as well. So we have 51,657 matched observations. If we cross check here, we should get 51,657. So that means we have successfully merged all the data into one file. So you can see that we have all the, and we can browse it also, browse, and you can see that here we have the A's, then B, then C, third level data, then D for the fourth level, E for fifth, and F for sixth level. So we have put the entire data set in one file. Now we will just drop this merge, and since now as we have a single, we can call it a master file of all the extracted data in one file. So we will save as. Now we will we'll go to the, and here we can save it as master file, or we can call it merged data set, and we can save it here, and it has been saved. So now we can close it, and now we can see that our merged data set is here. We will open it, and you can see that we have all the variables in one file. So finally we have successfully merged all the data sets, and we have applied all the and we have applied weights to it. So it was I am sorry that it was a very long and tiring process, but what can be done? It is a long and tiring process. It is not at all difficult. It is just that we aren't explained properly about how to go about it, and what are the process we have to start we have to do, what are the things that we have to be careful about, where we have to use 1:1, 1:1, 1:m, all those things. What are the common errors that we can encounter, and other things. So finally we have done it, and this has been a long video. Thank you all for patiently being with me till the end of the video. Thank you so much for watching the video. Like the video and subscribe to our channel for more comments, for more content like this. And please do write in the comment section box that what all topics do you want to cover, do you want us to cover in the upcoming videos. Thank you again. Thank you once again. Goodbye.